Hello, in this video I'm going to be talking about a quick demonstration of how a small processor works. Today I'm going to try an arithmetic operation of 8 minus 3, and I'm going to show you exactly how this is processed through an arithmetic logic unit, an ALU. That ALU unit is standing over here. It is part of our processing side over here. We also have our memory allocations down here. We have two sections, one that is read-only and one that is our access to what is going to be written. And so in order to start, we want to read in our values and then store them in order to do the operation before we write them into our memory. So to read everything, we want to make sure our read switch is turned on. So turn that switch on, we're going to see all of these green lights being connected. So right now our address is accessing our ROM0. We want to make sure that's number 8. Our ROM2 is going to be acting as our number 3. That's going to be 0011. So since we're accessing number 8 at the moment, we're going to want to subtract everything in our ALU. Our subtraction is under our mode 0, which is going to subtract A minus B. We have a register over here that is pretty much our B. So in order to get our proper value of 8 minus 3, 8 minus 3 is 5, we want to make sure our 8 is stored into our A, which is going to be up here. So our 8 is going to run through and it's going to be stored in this data bus. At the moment, it's going to be running directly in through here. And if we run a clock cycle, it's going to get stored into this register. We don't want that. We want it to go up. And we can't directly store anything if it stays up there. It's going to run directly into our processing over here. So what I'm going to do is switch over to my number 3 first. So we're going to change our address to number 1, access ROM1, pass in this number 3 directly into our register, and then get that stored. In order for this register to function, we have to switch it on with our enabler, and then we can run a clock cycle. We have the number 3 stored there. So now we're going to repeat the process by storing the number 8 on the top bus as I mentioned earlier. So we're going to access our first ROM piece of memory. It's going to be our number 8. We're going to send it directly to the top. Before we run our clock cycle, we want to make sure our enabler over here is off. It's not going to matter because our circuit isn't going to be transferring through this wire. We're going to turn on this switch right here, which is going to enable our data to go upwards. So once we have our number 8 and our number 3 right here, we can begin to our operation and see what our result is going to be. So we can see up here on our data bus that 0101 is the exact value of 5 that we are looking for, with our selection of 0 and our ALU making that arithmetic operation. So 8 minus 3 is giving us 5, making it correct. If we want to switch our options, if we do want to do 8 plus 3, that'll give us 11. And so that'll switch this over. That means we have the two proper numbers going in. If our number is higher than the bits that we have allocated, it's going to automatically switch to 1, and that's probably going to be not the result that you're looking for. We're going to be sticking with the subtraction, get our number 5, and we're going to pass this over into our accumulator register. Switch that on, pass in a clock cycle. We get that ready to be stored and ran through to be written. In order to write, we want to enable the switch to access this data to pass through the buffer, But since right now we're on read mode, everything is going to like error out. So we have to turn off the read and turn on the write. And now we have access directly to our random access memory at the bottom. So in order to access these, we can change our address one more time. And we can choose whichever one we want. I'm going to store it on RAM 7. It's the easiest one if I just turn on all of our addresses to number 1. And then we're going to run one more cycle in order for this value to get stored down here. Since right now it's at number 0, once we run the clock cycle, we can see that it's changed to number 5, and we get our final result. And that is my quick explanation on how we can get some value, get it read through a processor, get it processed through a arithmetic operation or whatever you need, have it stored, and then have it written at the end. Thank you for watching. Have a good day.